right? Overall mind map. So please copy this down. Please write down everything here. So first application is surface area. Okay, we have surface area. Surface area. This is the mind map. Saya nak buat mind map ni. Saya nak panah ke bawah lah. Okay. Surface area, before we can calculate the surface area, we need to identify what is our Z. Z is the function in terms of X and Y. Okay. So surface area means our region in 2D. Okay, region in 2D. So region R lah, involved for surface area, 2 dimensions. Okay. And the formula of surface area is ES equals to double integration towards region R. We will have square root of del Z over del X squared plus del Z over del Y squared plus 1. Okay. So this is the formula of surface area, and then this integration, of course, with respect to A. Okay, guys. So from this formula, you can use rectangular coordinate, or you can use polar coordinate. Okay, if your region R involves circle, you can use polar. It is much easier if you solve the double integration by using polar coordinates. It depends on your region R lah. You tengok region R awak apa. Kalau region R you just a straight line, you can use rectangular XYZ XY lah. But if your region involves circle, so better you guna R dr d theta. Okay. Right, so that's the formula of surface area. Next, I'm going to explain about the other applications. Okay, we have pecahan kat sini, mind map ni. And then we also have another one here. So, we have two objects here. We have the first one is lamina. Okay, lamina. And then the second one is solid. So lamina. And then this one is solid. Okay. Lamina is a very thin object. Okay, satu objek yang sangat nipis. We don't care about the height and it does not have thickness. Dia tak ada ketebalan. A very thin object. For example, okay, so lamina, since it's very thin, sangat nipis, so kita consider this as 2D problem. Okay, 2 dimensions only. And then for solid, of course, we have height lah. Kita ada ketinggian kan, so solid must be in 3D. Okay, so there are 2 main cases that you have to look at. Okay, so for example, lamina, we have like tissue. Okay, sehelai tissue, sangat nipis. Itu contoh lamina, a very thin object. And also A4 paper yang sangat nipis. Okay, and then what else? Kulit popia, you biasa makan popia ke, Vietnam roll ke, biasa makan popia tu? Kita tak pernah makan.
Yeah.
Itu pun examples of lamina lah. Satu helaian yang sangat nipis, objek yang sangat nipis, which is kita tak consider dia punya height. The dimension of height tu tak ada. So kita hanya consider dia 2D, 2 dimension sahaja. Okay, and then solid, of course lah, semua benda solid ni tak kisahlah, silinder, parabola, itu semua solid lah di 3D Okay, so now the first applications, number 1, we have mesh. Okay, so of course saya akan buat dua-dua lah, mesh dalam 2D and then mesh in 3D. Mass juga ni. Okay, so mass into D, we have the formula of mass equals to M. Okay, so means bila to D, of course, automatically double integration. So our region is region R. Okay, and then we will have a density function in the middle of integration. So when we have double integrals, of course, we will have dA. Okay, so this is called as the density function. Ni nama dia density function. Normally in the question, okay, the density function will be provided. Okay. So again, dA can be dy dx or dx dy, or if you have circle, then your integration would be r dr d theta lah. Kalau you guna polar So dA can be either one lah. Sama ada you guna rectangular dy dx or dx dy, or you can use polar. So bila polar, dA ni akan jadi tiga beradik tu, r dr d theta. Okay, so that is the formula of mass in 2 dimension. Now we go to the formula of mass in 3 dimension. Okay, M equals to triple integrations. Okay, so since we have 3D, so our region should be region G. Okay, so region G, and then our density function, dia akan jadi 3 variables lah. X, Y and Z, sebab dia 3D kan. So D apa ya kat belakang ni kalau triple integrals?
V.
Yes, dV. Okay, so now guys, you have to understand, right? dV, okay, dV ni it can be either dz dy dx, itu untuk rectangular. Okay, kalau case yang melibatkan betul-betul silinder, paraboloid, you can use cylindrical coordinates, which dV akan jadi 4 beradik tu, r dz dr d theta. Okay, and also if your region involves sphere, kalau solid kita melibatkan sphere ke hemisphere ke, we can use spherical coordinates. Alright, so not necessarily XYZ, sentiasa guna XYZ lah, not necessarily, okay. You have to apply anything that make your calculation easier. You kena bijak lah, okay. Kalau case tu melibatkan solid tu sphere or hemisphere, better you use spherical coordinates. So your dV will be 5 beradik tu, ada 5 terms tu. Rho squared, sin phi, d rho, d phi, d theta. Okay, so it depends on your region actually. Look at your region. Region you apa? Kalau region you setakat triangle, solid yang plain tu, better use XYZ lah. Tapi kalau you punya region G tu adalah melibatkan cone ataupun cylinder, better you use cylindrical coordinates. Tapi kalau melibatkan sphere, better use spherical coordinates. So it depends on your solid, depends on your region lah. Okay, so that's mass, the formula of mass. Next, number 2, we will have center of gravity. Okay, center of gravity. Sama lah, in 3D pun kita ada center of gravity. So we have this formula. Okay, before that, let me give you a brief definition lah. What is center of gravity? Okay, center of gravity, saya buat kat tengah-tengah Center of gravity, the definition. This is a point, the point, the point at which the weight is evenly dispersed and all sides are balanced. Okay, so the keyword for center of gravity is the weight. Ni keyword dia. Okay, so what's the formula of center of gravity in 2 dimension? So in 2 dimension, we will have center of gravity. Of course, we have X bar and Y bar only. Okay, we will have a coordinate lah. Sebab dia kata tadi, center of gravity means a point. Okay, the point. So in 2D, we only have X bar and Y bar. Okay, so the formula of X bar equals to 1 over mass. Okay, kenapa 1 over mass? M ni yang tadi ni, yang kita calculate tadi ni. Ni M, mass. Okay, 1 over mass because as I mentioned earlier, center of gravity related with weight. Berat dia. So that's why we use mass in the formula of calculating center of gravity. So 1 over mass multiplied by double integration towards region R. Okay, and then we have X multiplied by the density function, dA. Okay, so that is the formula of X bar. And then for Y bar, we have 1 over M multiplied by double integration of Y multiplied with the density function, xy dA. So that is center gravity in 2 dimensions. Okay, now the formula of center of gravity in 3 dimensions, we will have X bar, Y bar and Z bar. Okay, sebab dia 3D kan? So the formula of X bar in center of gravity in 3D, again we have 1 over M. Okay, the same formula. But now the density function, of course, x, y, z lah. dA. And then guys, sorry, not a double integral, but triple integral, sorry. Saya tersilap ni. Sorry, not dA, but dV. 3D kan? G dV. Okay, macam tu. And then, actually, the limit of this center of gravity, dia mesti sama dengan mass, guys. The limit must be the same as the limit for mass. Never mind, I will show you later through examples. Kita tengok example pula. Exercise kita nanti kita akan buat soalan center of gravity. Nanti saya explain. Okay, next we have Y bar over 1 over M, triple integrals towards region G. Y darab dengan density function x, y, z dV. Okay, and the last one we have Z bar equals to 1 over M, triple integrals of region G. Ni Z lah. Multiply with density function x, y, z and then dV. Okay, so that are the formulas of center of gravity for 3D. Solid lah maksudnya, solid Okay, next, 1, 2, 3. Number 3, we have centroid. Okay, so centroid in 2D and then centroid in 3D. Centroid. Okay, what is centroid? Centroid is the geometrical center of an object. Okay, geometrical center of an object. That's the definition, or I mean, not really definition lah. It's just summary of meaning of centroid lah. Macam tu. So the formula of centroid sama juga macam center of gravity. We will have X bar and Y bar in 2D. In 3D, we will have X bar, Y bar and Z bar. Okay. Berbeza dengan center of gravity. Center of gravity dia mesti related dengan mass. Sebab dia punya definition pun melibatkan weight kan, berat. But now for centroid, okay guys, for centroid, we will have in 2D X bar equals to 1 over A. Okay, A means the area. Okay, area. So, before you can calculate the X bar, in order to find the centroid, you have to calculate area. Okay, nak calculate area ni, you can use double integrations lah, of course. Okay, or you can double check with the formula of area lah. Formula of area of circle ke, area of triangle ke, macam tu. Okay, so by hook or by crook, we need to calculate area first before we can find the centroid. And then we have double integrals towards region R. So now we only have X. No need for you to multiply with density function. Okay, kalau centroid, dia tak perlu darab dengan density function lah. Okay, kalau center of gravity, you kena multiply X2 dengan density function. But in centroid, we just have X only. Okay, no need for you, no density function involved for centroid. Tak perlu density function. Okay, and then next is y bar. Y bar equals to 1 over A, area, double integrals of y, okay, and then dA lah. Okay, that's the formula of centroid in 2D. Okay, now centroid in 3D. Okay guys, we have x bar equals to, kalau tadi in 2D we calculate area, but now in 3D we have to calculate volume. Okay, so 1 over V. V means volume lah. Of course, you can calculate volume by using triple integrations. Okay, kita dah belajar sebelum ni kan, calculate volume guna triple integrals. So maksudnya you kena kira volume dulu, baru you can find the x bar, y bar and z bar. So we have triple integrals, G, and then we have X. So dV lah, of course, because 3D. And then Y bar equals to 1 over volume in triple integration, Y dV. And then Z bar equals to 1 over V, triple integrals of region G, Z dV. Okay, so basically these are the overall applications in your syllabus. Okay, we have surface area, we have mass, we have center of gravity, we also have centroid. Okay, now let's take a look at exercise 4.7. Question number 1. Okay. Find the surface area. The question asks you to find the surface area. Okay, so we start with surface area lah first ni. Question number 1. Dia siap bagi hint lagi ni. So we have to use the hint. Okay. So, surface area. Okay, the formula of surface area. Let us copy this. Oh, undo. If you look at the formula of surface area, we need to have region R. Okay, surface area melibatkan region R. Because it must be in 2D. So if we read this question, the portion of the cylinder that is above the rectangle. So right now guys, our region R is a rectangle. Okay, this is region R. Ni, dia dah bagi siap-siap lah. This is our region R, a rectangular region. Alright. So let's say I sketch juga cylinder ni so that you can see the overall view of this problem. So let's say I'm going to sketch this cylinder. X squared plus Z squared equals to 4 in 3D. So 3D. Guys, in final exam, if the question asks you to find surface area, actually no need for you to sketch 3D region. You just straight away sketch 2D region. Yang saya buat ni just to give you a better understanding lah of this problem. X, Y, Z. Okay, we have a cylinder. Dia kata apa tadi? X squared plus Z squared equals to 4. So, there is no Y in this equation of cylinder, right? So, which means that the cylinder must be parallel along which axis? Y axis lah. Okay. We don't have Y here, no Y. Okay, no Y. So this cylinder must be parallel along Y axis. So let's say we have this. Okay. And then I have like this. Okay, so that's the cylinder parallel along Y axis. So right now we have here should be the radius should be 2. Okay, because ni 4 kan. So 4 jadinya 2 lah. So here should be 2, at the back is negative 2. Macam tu. Okay, now guys, I would like to ask you, this is your region G because we have a cylinder region G. If you see from above, you can see a what? You nampak bentuk apa daripada atas kalau you tengok cylinder tu daripada atas? View from above. Yes, a rectangle, kan? Okay, we will have a rectangle. Very good. So we will have this. Something looks like this. Dia mesti macam ni. You akan dapat bentuk macam ni. Okay, so this is your region lah. Macam tu. Okay, so that's why we have this region. Dia dah bagi specific dah, rectangle region, region R. So tadi ni region G. So if I sketch region R, ni baru penting. This is the important part. Sebab kita nak buat surface area. So surface area, of course region kita 2D je lah, X, Y. So X and Y. It said that the interval, we have X from -2 until 2. And then Y from 0 until 4. Okay, 0 until 4. So we have, yes, X from +2 until -2. And then Y until 4. Okay, so we have this region. Betul lah tu. Okay. So macam ni. Alright. And then kalau you tengok kita punya cylinder ni, dia stop sampai level Y equals to 4 lah. Sampai situ. So betul lah, we have a rectangular region. Okay, so now we need to find what is our Z. Why? Because we are going to find del Z del X and del Z del Y. So kena cari function Z. From here, from the question, we know that X squared plus Z squared equals to 4. So we need to find the function of Z. X squared plus Z squared equals to 4. So Z squared equals to 4 minus X squared. Therefore, function Z equals to square root of 4 minus X squared. So this is our Z. Next, we need to find del Z over del X. We have to differentiate Z terhadap X. So how do we differentiate this? Okay, this is equivalent to 4 minus X kuasa 2 to the power of half, isn't it? So we differentiate Z with respect to X. 1 over 2 comes forward here. So we have 4 minus X squared to the power of what?
-1 over 2.
Yes, -1 over 2 and then multiply with?
-2x.
Yes, -2x. Very good. So we can cancel this 2 and -2 ni. So we will have -x. Power -half becomes the denominator. So -x over square root of 4 minus x squared. Macam tu. So that is del Z del X. Next, we need to find del Z del Y. Del Z over del Y. Sebab kita nak ganti kat dalam formula ni tadi. Dia ada del Z del X, dia ada del Z del Y. So we need to differentiate this function z with respect to y. Okay, my question now, is there any y here? Dalam z ni ada y ke?
Oh.
No.
No, right?
No.
So therefore, differentiate with respect to y, we'll get what?
0.
0.
0, yes, very good. We will get 0. Okay, thus, the function will be like this, square root of del z over del x squared plus del z over del y squared plus 1 equals to square root of negative x over square root of 4 minus x squared plus 0 squared plus 1. So we will have square root of negative x jadi positive x squared, and then we can cancel the square root sign since square root sign squared, kan? So jadi 4 minus x squared sajalah. So plus 1. Okay, so we can multiply with this denominator. So equals to x squared 4 minus x squared plus jarak dia akan jadi 4 minus x squared over 4 minus x squared lah, kan? So we can equate the denominator, dia akan jadi x squared plus 4 minus x squared over 4 minus x squared. So we can cancel this. So it becomes square root of, tiba-tiba ping pula. Square root of 4 over 4 minus x squared. So if we simplify this, we can have 2 over square root of 4 minus x squared. Okay, so right now this is our function. Okay, 2 over square root of 4 minus x squared. Thus, our surface area equals to double integration. Okay, so now this is our region R. Of course, this becomes our limit of y and limit of x lah. Okay, so dia akan jadi limit of integration y from 0 until 4 and then x from negative 2 until 2. And then the middle function here should be this. Okay, should be this one. The middle function here sebab kita dah calculate siap-siap tadi. So just substitute 2 over square root of 4 minus x squared. And then we have dy dx. So let us calculate this integration. Okay, so we can take out 2. We have this term with respect to y. So overall, this is just a constant. So we have 2 over square root of 4 minus x squared. So integrate constant, we get y, substitute 0 and 4 dx. Okay, so 4 jadi 8 lah kan? 4 kan, gantikan substitute y equals to 4. 4 times 2 becomes 8. So 8 can be taken out. I take this out. Negative 2 until 2, so 1 over square root of 4 minus x squared dx. Understand? You get this, guys? Faham?
Yes, madam.
Okay, now you cannot solve this directly. Okay, you cannot solve this sebab because we have 1 over square root of 4 minus x squared. Unless kalau ada x kat tepi ni baru boleh cancel lah nanti kalau guna substitution. But now we cannot integrate this. So what happened here? We need to use the hint. Okay, we need to use this. Oops, sorry. Du over a squared minus u squared arcsine u over a. Okay, kita guna hint dia tu, use formula. Integration of du over square root of a squared minus u squared equals to shift sign u over a plus constant c. Kenapa ada constancy ni? Sebab dia tak ada limit Tapi dalam kes kita ni, no need for you to put C lah. Okay, so now jom kita compare. Dx is actually U. Okay. So we have x equals to U. And then A squared. Nanti confused. X equals to U. Okay, betul. And then 4 equals to A squared, isn't it? Ni, 4 adalah A squared kan? Sebab ni X, bawah ni X kan? U squared. Faham? 4 adalah A squared. Understand? Okay, so now since 4 equals to A squared, therefore A equals to 2 lah kan? Dah 4 adalah A squared. So A adalah 2. Therefore the integration would be 8. Dia akan jadi shift sign, arc sign U over A. So U kita adalah X. So shift sign X over 2 lah. Substitute 2 and negative 2. Boleh faham?
Boleh.
Okay, so now 8. We substitute the values of X. So kita akan ada arc sign 2 over 2 minus shift sign 2 over 2 like this, which is 8. Shift sign 2 over 2 is 1. Use your calculator. So shift sign negative 1. Okay, if you use your calculator, shift sign 1, we will get 90 degrees or pi over 2, isn't it? And then minus, kalau shift sign negative 1, you dapat apa? Tekan shift, tekan sign, tekan negative 1. We will get?
Negative pi over 2.
Yes, negative pi over 2. Okay, good. So we will have 8 pi. Sebab pi over 2 tambah pi over 2 jadi pi kan? So this is the answer. Okay. So next question. Alright, okay. Question number 2. We have the portion of the plane 2x minus 2y plus z equals to 4 in the fourth octant. Okay, kalau kita lukis 3D lah graf ni. Macam biasalah kalau soalan surface area, kalau dia tak suruh lukis 3D tak payah lukis guys. Saya buat ni just untuk you faham lah konsep keseluruhan objek tu macam mana. Okay, kalau dia tak suruh lukis, you tak payah lukis lah. You just straight away sketch region R sahaja, which is involving the X dengan Y Okay, so let's say saya sketch juga 3D untuk soalan ni. So we have 2x minus 2y plus z equals to 4. So divides everything by 4 using intercept form. 2 bahagi 4 jadi x over 2 minus 2 divide by 4 jadi y over 2 plus z over 4 equals to 1. So if we sketch this, x, y and z, so x equals to 2 positive. Depan lah. Y negative. Okay, we have negative 2. So negative 2 on the left. And then z equals to 4. So 4 up here. Alright, so this is our solid. This is the plane. Okay, from above we can see region R, isn't it? So the view from above means that the region R is this triangle. Dia mesti triangle ni. Okay, from above we can see that triangle. So the blue color here, the region here is region R. Okay, so if we sketch region R, betul tak ni dekat 4th octane? Betul lah, 4th octane. First, second, depan, belakang, depan balik. Macam tu. So region R must be the blue color here. X dengan Y. So Y -2 tadi kan? So -2, X is +2. So we have this. Okay, this is our region R. Now, what's the equation? What's the equation of this Y? Line ni, line garisan ni, hijau ni. What's the equation? Okay, asal-asal kita adalah X/2 minus Y/2 equals to 1, isn't it? So Y equals to?
X minus 2.
Y equals to X minus 2. Okay, well done. Very good. X minus 2, yes. X minus 2. Okay, so now you boleh agak tak limit integration kita? Boleh imagine tak limit of integration? So kalau kita ambil, kita kan nak region R tadi kan? So from bottom line to top line, limit of integration jadi from the lower limit should be Y equals to?
X minus 2.
Yes, X minus 2 until Y equals to?
2.
Iya ke tu?
0.
0. Yes, very good. How about X? X from where to where? From this limit, from this region.
0 to 2.
Yes, 0 until 2. Well done. So kita dah tahu dah daripada region R ini kita punya limit untuk integration nanti. Okay, tapi tak habis lagi ni. Belum we cannot integrate lagi sebab kita kena cari formula surface area. We need to find del Z del X, del Z del Y kan? Okay, so now from this equation 2x minus 2y plus z ni, minus 2y plus z equals to 4. We need to find z lah, of course. So z equals to 4 minus 2x plus 2y. Okay, so next step we have to find del z del x. So differentiate z with respect to x, you all dapat apa ni?
-2.
-2. Very simple, right? And del z over del y, we will get
2.
2. Yes, very good. So, gantikan dalam formula ni, del z over del x squared plus del z over del y squared plus 1. So, we will have square root of -2 squared plus 2 squared plus 1. So 4 tambah 4, 8 tambah 1, 9. Square root of 9, so it becomes 3. Okay, so now we can proceed calculating the surface area. Equals to double integration. Yang tadi tu lah limit tadi tu. Yang saya suruh you cari berdasarkan region R tadi tu. So Y equals to from X minus 2 until 0. And then X daripada 0 sampai 2. 0 until 2. And then put 3 in the middle because we got 3 just now, right? And then dy dx. Okay, so dy dx. Okay, so we can take out 3 just a constant. 0 until 2, so substitute lah y 0 x minus 2 dx. So we will have 3 0 until 2, 0 minus x minus 2 dx. So it becomes 2 minus x kan, terbalik lah jadinya sebab negatif tu. So now we can integrate this to x minus x squared over 2, substitute 0 and 2. So 3, 2 times 2 is 4, 4 divided by 2, so 2. 3 times 2, we get 6. Okay, so this is the answer, 6. Okay, now if you notice in question number 1 dengan number 2, semua guna x dengan y. Okay, dA kita x dengan y kan, dy dx kan. Okay, so now let's take a look at question number, let's say number 3. It said that above the disk. Okay, kita ambil question number 3 ni, kita tengok region R dia bentuk apa. Question number 3. Okay, dia kata above the disk. See, highlight the keyword above the disk. This is, ni bentuk apa disk ni? Agak-agak guys, disk ni bentuk macam mana?
Circle.
Circle kan? Okay, so circle. Alright. So bila circle, it is much easier for you to use double integrals in polar coordinates. Better guna polar coordinates lah. Okay, never mind. Let's see, kita sketch dulu. Okay, macam biasa saya nak juga sketch 3D ni supaya you faham bentuk dia macam mana. We have a paraboloid. Paraboloid ni mangkuk tom yum. Mangkuk tom yum menghadap ke atas, upward ke downward ni? Upward or downward? Upward lah, positif kan? Okay, very good. So dia akan ke atas lah. Okay, mangkuk tom yum yang menghadap ke atas ni. Okay, now dia tak begitu curve. Saya nak curve bulat sikit. Macam tu. Okay. This paraboloid above the disk. So disk kita x squared plus y squared equals to 4. I'm going to use the blue color. So of course if you can see from above, we can see this bentuk bulat ni lah. Okay. Of course the value here should be 2, 2, negative 2. Here negative 2. Ni. So itu bentuk asal solid ni lah, paraboloid above the disk. So if we straight away sketch region R, we can see, we can have this X and Y. So we can have this region. Okay, so the radius is 2 because x squared plus y squared equals to 4 kan. Okay guys, now this is your region R. As I mentioned earlier, it's better for you to use double integral in polar coordinate because we have a region R in terms of circle. Okay, so what happened? Okay, what happened here guys? Kita punya double integration akan jadi limit kita. If you can see from here, what's the limit for radius? R equals to what? From where to where?
0 to 2.
Yeah, 0 until 2. And theta from?
0 to 2 pi.
Yeah, 0 until 2 pi. Yes, okay. So it's much easier. Kalau you guna rectangular, you kena ada square root of. You kena you kena buat macam ni pula. Jadi y equals to square root of 4 minus x squared, atas bawah pening kepala. So better kalau if you encounter this type of region in your final exam, better, okay, lepas ni, minggu depan lagi sekali ni, kalau jumpa je bentuk circle, it's better use polar. Itu kalau double integration. If triple integrations, better use either cylindrical or spherical lah. Okay. So now, so kita dah tahu dah kita punya limit. Okay, next kita kena cari kita punya function z ni. Del z, del x, del z, del y lah. Okay, z equals to x squared plus y squared. So del z over del x equals to 2x and del z over del y equals to 2y. So we will have square root of del z over del x squared plus del z over del y squared plus 1. Dia jadi 2x squared plus 2y squared plus 1. Then we have 4x squared plus 4y squared plus 1. Okay, now guys, when you decide to use polar coordinate, means you cannot have variable x and y anymore. Dah tak boleh ada x dengan y dah dalam function integral kita. So what to do is you have to convert this into r or theta. Okay, so if we modify this equation, it becomes 4x squared plus y squared, isn't it? So now, apa jadi? Kalau x squared plus y squared ni, kita boleh convert kepada polar coordinate. This is equals to?
R squared.
Yes, very good. So we will have square root of 4r squared plus 1 like this. So this will be our the middle function in our integration. Okay, therefore, surface area equals to double integration. Okay, we take the limit here in the red color ni yang kita cari tadi ni. So 0 until 2, and then we have 0 until 2 pi. And then we have square root of 4r squared plus 1. Lepas tu belakang dia apa?
R d theta.
Yes, very good. We have r dr d theta. Ingat dalam kepala, kalau polar je ada 3 beradik. R dr d theta. Okay. So now, how do we solve this? Macam mana nak solvekan ni? Integration ada square root of lagi ni. We need to make a substitution. Okay, so we let u equals to 4r squared plus 1 like this. So let u equals to 4r squared plus 1. Next, we need to differentiate our r. Sorry, differentiate u. We will get 8r dr. Okay. So of course, dr akan jadi du over 8r lah. Alright, so macam biasa, I like to change the limit at first. It up to you kan. Kalau you selesa tukar limit kemudian, boleh. Nak tukar kemudian pun boleh. Macam saya suka tukar terus. So terpulang lah masing-masing Okay, so when r equals to 2, we will have u equals to 4 times 2 squared plus 1. So 4 times 4, 16 plus 1, 17. Okay, and then when r equals to 0, we will have u equals to 4 times 0 squared plus 1. So we have 1. Okay, therefore the integration becomes 0 until 2 pi, tak berubah. And then 2 jadi 17, 0 jadi 1. Okay, yang dalam ni the whole thing, this is square root u lah of course. So square root u. Alright, r darab dr. dr is actually du over 8r. So du over 8r d theta. D theta salin balik je. Okay, so now we can cancel this r. 1 over 8 can be taken out. So 1 over 8, 0 until 2 pi, 1 until 17. So u ni actually u to the power of half lah. Differentiate du d theta. So u to the power of half dia akan jadi 0 until 2 pi u to the power of 3 over 2, isn't it? 1 per 2 tambah 1. So over 3 over 2, it becomes 2 over 3. Like this. So substitute 17 and 1 d theta. So overall, over 8, 2 over 3 can be taken out. 0 until 2 pi. Substitute jadi 17 to the power of 3 over 2 minus 1 lah. 1 to the power of 3 over 2 sama. Okay, so the whole thing is just a constant. Lagi satu kita boleh cancel yang ni. This one becomes 4. So dia akan jadi 1 over 12 kan. 4 kali 3, 12. So ni boleh bawa keluar. 0 until 2 pi d theta. So of course becomes 2 pi. So this one can cancel. Jadi 6. Okay. So we have pi over 6, 17 to the power of 3 over 2 minus 1. Like that. Okay, so this is the answer. Sekejap, betul ke tak Question number berapa tadi? 3 1 over 6. Yes, okay. Alright. So we finished already for question number 3. Okay, that's for surface area lah. Okay, so now we go to center of gravity. Kita tengok soalan center of gravity. Okay, look at question number 7. Find mass and center of gravity. Okay, find mass and center of gravity of the lamina. Dia kata lamina. Kalau lamina, what's the dimension of lamina? 2D or 3D?
2D.
Yes, very good. 2D. Okay. So bila 2D, region apa yang terlibat?
R.
Yes, very good. Region R. Copy. Okay. This one. Question number 3 pula. Kenapa dia tak copy? Kejap Okay, question 7, mass and lamina. Mass and lamina pula. Mass and center of gravity. Okay. So now, let us sketch region R. Okay, sebab dia melibatkan lamina. When lamina means 2D lah. 2D, so we are dealing with region R. Okay, so let us sketch the region R. Region R, 2D, part CX dengan Y. Bounded by the y-axis, line y equals to 1 and the curve y equals to x squared. So y equals to x squared is like this. Okay, this is y equals to x squared. And then the line y equals to 1. So y equals to 1. We have a straight line like this. Let's see it here. Okay, so guys, kalau kat sini, this is the region in the first quadrant lah. Okay, first quadrant. So what's the coordinate here? Apa coordinate x kat situ?
1.
1. Okay, good. Very good. 1. So now, if I ask you the limit, okay, so this is the region kan? From above to top. What's the limit? Limit of y from where to where?
X squared.
Yes, y equals to x squared until y equals to 1. Okay, good. Very good. How about x? X from 0 until x equals to 1. Okay, so that's our limit of integration. So settle. Now, jom kita cari kita punya mass. Okay, mass M equals to double integration towards region R, density function of xy dA. Okay, so in this equation, we are given the density function as x plus y. Dia bagi x plus y as the density function. So we can straight away substitute in this integration, x plus y. Okay. So we have dA, of course dy dx lah. Kita dah decide tadi kan. So limit bawah kita x squared, 1, 0 and 1 like this. So we can proceed 0 until 1, xy plus y squared over 2, substitute x squared and 1 dx. Okay, so we have 0 until 1, x plus 1 over 2 minus x kuasa 2 darab x kuasa 3 lah, plus x to the power of 4 over 2 dx. Okay, so now we will have 0 until 1, x plus 1 over 2 minus x cubed plus pula minus x to the power of 4 over 2 dx. Baru integrate. So dia jadi x squared over 2 plus x over 2 minus x to the power of 4 over 4 minus x to the power of 5 over 5 times 2 is 10. So 0 and 1. 1 over 2 plus 1 over 2 minus 1 over 4 minus 1 over 10. Cuba you all kira dapat apa ni? What's the answer, guys?
13 over 20.
Yes, 13 over 20. Betul tak? Tengok dulu. Soal nombor apa? 7 tadi. 13 over 20, yes. Okay, good. Itu mass. Next, you all kena cari center of gravity. So, jom cari center of gravity. X bar and Y bar. So, X bar, 1 over M, double integration towards region R, X multiplied by the density function, dA. Okay, so 1 over berapa M tadi? 13/20. So, 13 over 20. Multiply by, use the same limit as the previous step. Okay, so we will use the same limit. Ni lah, sama je. Density function pun pakai density function yang sama lah. So we will have x squared until 1, 0 until 1. But now we have to multiply with x. Okay, so x darabkan dengan density function x plus y tadi. So we have dy dx. We can proceed. Now 13 over 20 becomes 20 over 13 lah. Dia terbalik. 0 and 1. So now 20 over 13, 0 and 1. X squared y plus xy squared over 2. Substitute x squared 1 dx. So we have 20 over 13, 0 until 1. X kuasa 2 tambah x over 2 minus x kuasa 2, x kuasa 4 lah. Tambah x kuasa 5 yalah, x kuasa 5 over 2 dx. So kita boleh integrate dah ni, dia akan jadi x cube over 3 plus x squared over 2 times 2 is 4 minus x to the power of 5 over 5. Ni you have to be careful. Minus plus become minus. X to the power of 6 times 2 is 12. 0, 1. So we will have 20 over 13. 1 over 3 plus 1 over 4 minus 1 over 5 minus 1 over 12. Dapat apa ni? Cuba kira. Betul tak? Kalau ada salah boleh tahu Saya takut saya termistake apa. Dapat berapa ni?
6 over 13.
6 over 13.
Yes.
Jom kita tengok betul tak? Okay, yes. 6 over 13. Thank you very much. Okay, so next itu baru y bar. X bar. So next kena cari y bar lah. Coordinate y. 1 over m double integration towards region R, y. Sekarang ni y pula darab dengan density function. We have dA. So right now 1 over berapa kemis kita tadi tu? 13 over 20. So 1 over 13 over 20. The same limit 0 until 1, x squared until 1, y, density function kita tadi, x plus y, dy dx. So we will have 20 over 13, 0 until 1, yx. Sekejap, saya kembang dulu lah. So dia jadi xy plus y squared, dy dx. Okay, baru kita integrate. xy squared over 2 plus y cubed over 3. Substitute x squared and 1 dx. Gantikan 1 pada y. We will have x over 2 plus 1 over 3 minus x squared, x to the power of 4 jadi x to the power of 5 over 2 plus 2 kuasa 3. So x to the power of 6 lah, over 3 dx. So now let us integrate this function. It becomes x squared over 4. Ya ke? 2 kali 2, 4. Betul lah. Tambah x over 3 minus x to the power of 6 over 6 times 2 is 12. Plus minus Oops, sorry. Minus plus ni. So jadi minus. 6 jadi 7. 7 times 3 is 21. Substitute 1, 0. So we have 20 over 13. Darabkan dengan 1 over 4 plus 1 over 3 minus 1 over 12 minus 1 over 21. Dapat apa guys? What should you get?
190 per
100?
200.
Berapa 190? Apa?
190.
190 per apa?
273.
273. Sekejap. Betul ke ni? Okay, 190 over 273. Okay, done. Settle. Okay, so that's the answer for this center of gravity. Okay, next we go to the centroid. Ada tak soalan centroid? Okay. Okay. Tetrahedron. Find the volume and centroid. Volume and centroid of the solid. Okay. Tetrahedron ni lebih kurang macam tadi lah. Saya nak yang ada bentuk circle-circle. Okay, I think question number 10 bentuk circle. Okay, yes. Saya nak guna cylindrical. Sebab tadi kita dah pakai XYZ kan. So kita pakai cylindrical untuk soalan ni. Question number berapa saya ambil tadi? Question number 10 lah. Okay. Question 10. Centroid Centroid. Question 10. Okay, if you read the question, it said that solid. Solid means our region should be 3D or 2D?
3D.
3D.
Yes, 3D So bila final exam nanti baca soalan betul-betul guys. Dia solid ke ataupun dia lamina. Okay, solid ni dan solid ni boleh macam-macam. Kadang dia terus sebut a plane. So kalau a plane tu dia adalah solid. Kadang-kadang disebut a paraboloid. Itu solid. Okay. Lamina ni, kalau lamina dia memang sebut lamina. Tapi solid can be anything lah. Solid ni banyak. So be careful lah in final exam Okay, so means dalam case ni dia 3D lah. Tadi center of gravity, contoh soalan kita lamina, that's why 2D. But now in question number 10, straight away they said solid. So solid means centroid in 3D lah. Okay, so we need to sketch region G. Sebab dia 3D kan. So region G. X, Y, and Z. Paraboloid, mangkuk tom yum. Upward or downward?
Downward.
Downward, very good. Because we have negative ni, tips dia negative. So dia jadi downward lah. Okay, very good. So we have a downward paraboloid like this. Okay. The value here should be berapa nilai kat atas Z ni?
4.
4. Okay, very good. How about this? Kita ada circle kat bawah. What's the values here? And here and here. Chapter 1 ni. Kita belajar 3D sketching. Berapa nilai bawah tu dekat XY plane?
2.
2. Yes, very good. 2. Macam nak tahu negative 2. Okay, here negative 2. On XY plane kan Z equals to 0 kan? Kita recall balik lah Lalang dah nak final exam ni. So Z equals to 0. So when Z equals to 4 minus X squared minus Y squared. So we have 0 equals to 4 minus X squared minus Y squared. Therefore X squared plus Y squared equals to 4. R squared equals to 4. Therefore R equals to 2. Okay, so if we can see from above, we can see the region R. Okay, so we will have a circle, complete circle. Ini saya kata tadi ni, kalau region R kita melibatkan circle, okay, region R is a complete circle with radius 2, X and Y. Ni 2. So we know that radius is from 0 until 2. And how about theta? Complete circle. We will have 0 until 2 pi. Okay. So now, ni triple integration sebab dia solid 3D. So triple integration. Alright. First, what we should do is, in order to find the centroid, we need to find the volume. Sebab bila 3D, kita kena calculate volume. Tengok formula atas ni. Ni. Kalau centroid 3D, you have to calculate the volume first. So let us calculate the volume of this paraboloid. Volume. Triple integrals. Okay. Now, it's better for you to use cylindrical coordinate sebab dia melibatkan paraboloid lah. And then circle dalam 2D. So, dalam ni Z equals to what? From where to where? Limit of Z. Ni, 3D ni. Daripada tapak. Tapak means Z equals to?
0 to 4.
0.
0 lah. Okay, Z equals to 0. However, guys, you have to be careful. Limit bawah kita tapak memang 0. Tapi bumbung kita yang ni. This is upper limit of Z. So, this is Z equals to 4 minus X squared minus Y squared, isn't it? Okay, ini dalam X dengan Y. Kalau tukar kepada cylindrical coordinates, Z equals to 4 minus, dia jadi macam ni kan? Tambah Y kuasa 2, which is equivalent to Z equals to 4 minus R squared. Be careful dalam final exam, dia bukan jadi 4 saja, dia jadi equation tu. Sebab dia the whole roof, dia bumbung paraboloid tu. So it becomes 4 minus R squared. So the limit here is 4 minus R squared. Okay, now how about the radius and theta? Of course, we can see from region R. Okay, so 0 until 2 and 0 until 2 pi. Okay, calculate volume. Tengah-tengah ada function tak?
Tak ada.
Tak ada. So tak ada, dia jadi 1 je kan? Okay, lepas tu, okay 1. Lepas tu, dia ada apa kat belakang? Right now.
R, D, Z, D, R, D.
Yes, very good. R, dz, dr, d theta. Ada 4 beradik. You have to remember that. Kalau cylindrical, dia ada 4 terms. 4 terms. R, dz, dr, d theta. Okay, now baru kita boleh cari kita punya volume ni. 0 until 2 pi, 0 until 2. Integrate 1 with respect to Z, we will get Z lah. Substitute 4 minus R squared, 0, R, dr, d theta. So we have 0 until 2 pi, 0 until 2. So 4 minus r squared multiply with r dr d theta. So 4r minus r cubed dr d theta. Okay, now we can integrate this. Okay, we will have 0 until 2 pi. So 4r dia jadi 2r squared lah. R kuasa 2 bagi 2 kan. Minus r to the power of 4 over 4, 0 until 2 d theta. So we have 0 until 2 pi. 2 kuasa 2, 4 kali 2, 8. Tolak 16 bagi 4, 4. So 8 minus 4 should be 4, can be taken out. 0 until 2 pi d theta. So 4 we have theta is 2 pi. So we will have 8 pi. Ni baru volume, belum habis lagi ni. So we need to find x bar, y bar and z bar. Okay, so now the centroid. X bar, y bar and z bar. Okay, x bar equals to 1 over volume, triple integrals towards region G. We will have x, okay, dv, like this. So 1 over volume, 1 over 8 pi, okay, 1 over 8 pi, triple integral 0 until 2 pi, 0 until 2, 0 until 4 minus r squared yang tadi. Okay, and then x. X ni kena letak x ke? Kena letak apa x ni? Kena gantikan dalam jadi polar kan? Because we use cylindrical coordinate. So x in polar is what?
R cos theta.
Yes, very good. R cos theta. Okay. So r cos theta multiply with r dz dr d theta. Macam tu. Okay, guys. If you calculate this, okay, if you calculate this, you will get equals to 0. Tahu? Kenapa? I give you tips Because, okay, this is for centroid dalam centroid, tips sikit lah. Tips for centroid. Okay, if you look at region R, kalau dia symmetric pula about x-axis, means y bar dia equals to 0. Okay, if the region R symmetric about y-axis, means the x bar equals to 0. Okay, so in this case, graf kita ni, kalau you tengok region R ni, dia memang akan jadi 0 lah. You tengok ni, region R kita ni, dia symmetric pada x, symmetric pada y kan? Both kan? Betul tak? Faham tak konsep symmetric? You lipat pada paksi y, you dapat 2 ni jadi negatif 2. Sebelah sini, dia symmetric lah. 2 kat atas jadi negatif 2 kat bawah. So dia symmetric. So x bar dengan y bar dia 0. Okay, tak percaya you try kira, you akan dapat 0. Okay, and then y bar pun sama, 1 over v g y dv. We have 1 over 8 pi, 0 until 2 pi, 0 until 2, 0 until 4 minus r squared. We have r sin theta lah, sebab r. Sebab y. Okay, so r dz dr d theta. Yang ni pun you will get 0 actually. Macam tu. Okay. So now, we will have z. Z je saja yang kita kena kira. Okay. So z we will have 1 over volume, triple integrals towards region G. We will have z dv. So 1 over volume. Volume kita tadi berapa? 8 pi kan? 8 pi. triple integrals 0 until 4 minus r squared, 0 until 2, 0 until 2 pi. Lepas tu apa ni? Z jadi apa dalam cylindrical? Kalau cylindrical, kita punya ni R theta Z kan? So Z maintain lah cylindrical. Kalau spherical baru Z ada formula. Z equals to rho cos phi. Tapi dalam cylindrical Z tetap Z lah. So Z. Okay, and then dV is multiply with R dZ dr d theta. Okay, so we can calculate this. 8 pi. 0 until 2 pi, 0 until 2. So it becomes Z squared over 2. Substitute 0 until 4 minus R squared darab dengan R dr d theta. So we will have 1 over 2 ni saya nak bawa keluar. So we will have 1 over 16 pi. 2 pi 0 until 2. So 4 minus R squared multiply with R dr d theta. So let us expand this 0 until 2 pi. So jadi 16 minus 2 times 4 is 8 r squared plus r to the power of 4 multiply with r dr d theta. So we will have 1 over 16 pi and then 0 until 2 pi. So darab lah, masuk dulu. 16r minus 8r cubed plus r to the power of 5 dr d theta. Okay, now baru kita boleh integrate 1 over 16 pi. 0 until 2 pi, so 16. Jadi divide by 2, 8r squared lah. 8 bahagi 4. Jadi 2 r to the power of 4 plus r to the power of 6 kan? Over 6. Substitute 0 and 2 d theta. So kita ada 1 over 16 pi. What is 2 kali 2, 4, 8. 8 kali 4, 32. Sorry, 32. 2 to the power of 4, 16. 32 plus 2 to the power of 32 times 2, 64 over 6 d theta. So 32 habis. 64 over 6 boleh bawa keluar. 1 over 16 pi, 64 over 6. So integrate 0 until 2 pi d theta. So we will have 1 over 16 pi. 64 over 6 multiply by 2 pi. So ini boleh kecilkan lagi ni. Okay, this one jadi 3. This one jadi 1 lah. Okay, and then sorry. This one jadi 1, 64 bagi 16. Jadi 4 kan? 16 kali 4, 24, betul lah. So we will have 4 over 3. Okay, jom kita tengok betul tak question number 10. Yes, 0, 0. See? X bar 0, Y bar 0, Z equals to 4 over 3. You try calculate, memang you akan dapat 0. X bar dengan Y bar tu. Okay. So now the centroid. Therefore, the centroid is 0, 0, 4 over 3. Okay. So understand, guys? Do you understand?